Hello everybody and welcome to the wonderful world of wireless redstone. And in this video I'm going to show you how you can create receivers and transmitters and receivers for endopostasis chambers that you can address anywhere in the world. And yeah, this version of wireless redstone builds on everything that Cubicmetre has shown on YouTube. Go ahead and check him out. I'll put the link to his video in the description, and he's done a fabulous job explaining all the mechanics. You can go look there, but I will also go through everything and how it works. And this is even his redstone testing world, so you can check out everything that he has created. But I've come up with a separate new, it builds on what he has done, but it's a separate new address system that you can use for to easily set up stations, and you don't have to do any of the binary and binary encoding and packages of data. Is just a single frequency thing. So I thought it was a good idea, so I just want to show you what I've done. In this video, I'll go through how wireless redstone works. Doing item falling. There's also a different version of wireless redstone using water updates, but this one is just it doesn't lag your game. It's just items that are falling. I go through how the mechanics work. Then I'll show you how you can arrange signal frames and how you can mess with them to manipulate how items fall. And these protocols that you can create will allow you to create receivers and transmitters. So then I'll go how you can build these and how the receivers and transmitters work that I've created. I'll explain them to you, and then in the end I'm gonna take a look at the address system that I've created. Okay, so first up, in Minecraft there's a game mechanic that when you create items in the same game tick, the game gives the same behavior, falling behavior, to every other item. So the first item will fall first, and then the second item will start falling, and the third item will again start falling at the same time as the first item. So if we create items, so every column here stands for an item created. You can see down there by the netherite and diamond blocks that every second item will experience the same falling behavior. And this we can test for if we create the item and put it in a chamber, and then we drop it at the same time, and we can see whether it falls at the same time, so it gets picked up at the same time by the hopper below, or if it does not. And for this, we have to create the items at exactly the same game tick, but in a very specified sequence. So yeah, so the way we can do this is using repeater and comparator tile sets, because the game will have, even though all of these combinations of repeaters all add up to 5 ticks of delay, they will have a very specific sequence in which they will fire. I can show you right here. If I fire them from the left, they turn up from the left to the right, and if I fire them from the right and now from the left, they will again have the same order. And this Cubicmetre does a great job explaining how this works. But the basic principle is that whenever a repeater is powered, it puts all the things that should be powered when it is fully turned on into a list. And so if a repeater on one tick gets powered, and also when these things that it powers should be turned on, they get all put into a list, and basically we can manipulate the order of the things in this list. They will still be the same things, so all of these repeaters will turn on all of these other repeaters, but we can determine in which order they will be in this list. And the game has a certain priority, and for basic explanation, this is the basic priority. So the fastest tile set, the fastest combination, or the fastest part in the combination is the single tick repeater, then the comparator, then 2, 3, 4. And so using this we can create combinations that in total have the same amount of delay, but are ordered in a specific way. So for example, this tile set and this tile set, they have the same amount, but this one has the higher priority. Using this we can create, using 2 or 3 or 4, however many we like, we create different combinations that have a very specific sequence. For example, right here you can see these are all the combinations for 3 parts. So they all end up to 6 ticks of delay, but since this one has a repeater first and this one has a comparator first, this one will get priority over that one. So when they are powered in the same game tick, and if we put a command block here, then this command block will turn on first and then that one. And using these priorities, we can create items in the same game tick in a very specific order, because they will be created in the order that we determine with this very certain set of combination of repeaters. So what we have right here is basically the same as we have it here from left to right. There's the decreasing priority. So when we power all of these at the same time, this one will turn on first, then that one, and so forth. And all of these lead into a dropper that creates an item. So but as you can see, this rail only powers these outside two and these outside two. So in the order that they will be created in this, first an item will dispensed here into the chamber, then into here, but it will be picked up right away. It's just a filler item. Then we go over here. Item will be another filler item, and then another one in the chamber. And as I've talked about it before, basically every other item will experience the same behavior. So the item in this chamber and this filler item here, they will experience the same behavior, and the same goes for this filler item and the item in this chamber right here. So basically what we have is the columns here all stand for an item created, and the high columns stand for ones that are being put into a chamber, the low columns for ones that are just filler items. And as you can see right here, the two items in the chambers, they are not on the same block, which means they will not experience the same behavior. So if we drop them at the same time, one will get picked up first and then the other one. So what we have down here is basically just a testing circuit that checks whether these two events happen at exactly the same time. And how we do this is that we quasi-power this dropper down here. The dropper is not going to notice unless we give it an update at exactly the same time. So it's powered for just one tick using this monostable circuit. And if in this one tick we update it, then it will fire. If we don't update it, nothing will happen. And the way we can update it is by using the other item and using these rails. And if these turn on at the same time or slightly after the dropper is powered, but not before the next game tick, then the dropper will fire and we will get an output. And but this will not happen because, or like in the circumstances I've described, this will not happen. The light will not turn on because these two are not happening at the same time. What we have to do in order for this light to turn on is fire another item in the middle, because if we do that in the order that the items are created, now the two items in the chambers, including the one in the middle, they all experience the same behavior because they are every other item spaced apart. And so if we create another item and put it in between, we can suddenly see that the items in the two chambers will line up and the light will turn on. And now what we can do is put the outside four items that are created, outside four droppers, on the left and on the right on one circuit using a globally synchronized clock, and the middle item that is the filler that will space them apart so that they will line up, that we can put on another daylight sensor globally synchronized clock. And what we also do is whenever we create an item, after some time we let it sit and then we let it fall to test it. So I'm quickly gonna turn this on so you can see. So, oh wait, I have to turn this on, this off. So, as you can see, there's always items created. Then they sit in here, and actually this should not turn on. I don't know why it is turning on right now. Let me quickly, maybe it's because it's too fast. Okay, it was working a second ago. What you should see, I can still show you by using a single item. Then it will work. So if I create a single item and not let it get dropped, if I create a single item, so it sits in here, and then I drop it, there will be no light turning on. But if I then create the item in the middle as well, this one right here, so all the 5 items are created, and then we check it, we can suddenly see that the light turns on. And now, right now it didn't work. That was because my timing is messed up here, because the repeater, the transmitter and receivers are working too fast. On the other circuits, this will be corrected. But what we can do is put this middle line here as a transmitter circuit, and these outside here as a receiver circuit that's testing the behavior of these 2 chambers. And that's basically how a wireless redstone works with item form mechanics. And using this, we can even use one side or many chambers on one side and one chamber on the other side as a reference. So these chambers, they will all be items that we can check against the reference. So we can even on one repeater, on one receiver, we can check for many different many different different frequencies, and the frequencies are basically just combinations of like a very specific point in the sequence. In a game tick, we can use that as a frequency. Oh, there's a misfire right here. Okay. So yeah, that's basically how the receivers and transmitters work. So a basic frame would look like this. So we have 3 different frequencies of items we test. And if we put an item in between one of these, let me quickly show you with or maybe orange is better. So like this. So put an item after orange, and the rest moves backwards. Then we can suddenly see that the orange and the white, they will line up. They will be every item space, every other item spaced apart. But when we do this, we can suddenly see, okay, yellow is also every other item spaced apart, so yellow will also turn on. So in order to use this with many frequencies, we can't just put an item in after our specific frequency, but also in front. So we separate the frequency we want to transmit on out from all the other frequencies. And you can also see that right here. Even if we have many receivers, it will still work, but the other frequencies will be separated out, or basically the frequencies that we want to receive on are separated out. So you can see by the diamond blocks here that they line up with the reference unit. So in order to do this, we have to create very specific combinations of repeaters. And the way I've done this is to use 3 repeaters or three parts to specify the station, and this will have the highest priority. Then as a subset, as a sub priority, you can specify which chamber you want to address, and then after that, as the lowest priority, even if all of these are the same, we can still manipulate in the front here whether we want the item to be an item that is going before the item that's go to the chamber and one that goes out, or if we wanted that this is the item that should be dropped, should be put in a chamber, or the item that should be a fill item after the chamber. So we have 3 different so they all share the same 6 base frequency parts, but for the item in front, the items that go for the chamber, and the item after, they will have each very specific modifier to the basic frequency. And that's basically how we can make sure that one goes in front, then the test chamber frequency comes, and then one goes behind. So yeah, if we then create a transmitter, it would look something like this. It's very simple. It's just a globally synchronized clock that fires into two of these lines. Right here we have two specific frequencies, or maybe this one is better to see. So it's two frequencies, and the later part is the same, but in the front we have one that has the frequency for item that goes before a frame, and one that goes for items that go after the frame. And in between of these, we'll have on the receiver circuit, which is right here, the frequency for the item that goes into the chamber. So basically we just let the signal go through here. So by the end of these will be ordered, or every event that goes on from here will be ordered by the order that we've created through these combinations of repeaters. And then we just fire the filler items in front and in the back. That's basically how the transmitter works. And the receiver is also very simple. We have the same frequency here, but in the beginning we have a different modifier. The modifier that is for the items that go in the chamber, so that the transmitter items will go in front and in the back, and in between there will be the receiver item. And we have another line that's for the reference channel. So basically everything you see here is basically just the same as over there, just rearranged. So we have a reference and a test channel, and they get checked against each other. So this is again a globally synchronized clock, which gives us a pulse. The pulse goes through here, and then we create items. Of course, we create filler items and we create items that go in the chamber at the same time. And then when we've created, after some time, we will drop the items, and we will see down here whether this dropper will get powered. So the channel is trying to power the dropper quasi connectivity, so it's not going to realize, and the reference channel using these rails will try to update it. And if it is indeed updated and fires, then we can detect that with an observer and pull the signal out to the front. And that's basically just how it works. Over here, and yes, right here I have these set right next to one another, but you can also put one on the top and one on the bottom, and then you can layer them left to right, and each slice is just one frequency with the item that opens the frame and the item that closes the frame on the bottom and on the top. And then you can have another frequency over here. So you can make these tileable, and the same goes over here for the receiver. These are also tileable right next to one another. But this is also basically all the same that Cubicmetre has shown, just with a different idea for the frequencies. Okay, and now what we can also do is create a universal transmitter that creates, again, the open frame and close frame signals. You can see two layers, top and bottom, for open and close frame. But then after that, we can basically stitch our signal together with the three parts. So the first part, that will always be the same, open and close. But the second two parts, we can basically determine and stitch them together. So if I, for example, want to go to the second chamber, or right now it's the first, so let me go to the second chamber. The second chamber on the 8th station, that 8th station is the blue one, we can see that the signal, the first two parts are here, then the signal goes through here and through this target block. Then the second part of the signal is here, then goes over here, goes through here, and then the third part of the signal is here. And then we create the two filler items, basically the same thing as over there. So using this, we can stitch together any signal that we want to create. And using this, you also don't have to build it this big if you don't make use of all the 16 different or 15 different frequencies chamber station. You can just build like up onto here, maybe like 5 or something. It doesn't need to be this big. And if we do this, and we have a receiver circuit which is the same as over there, with the frequencies, then we can send signals here. And of course the receivers, they always have their own frequency marker in the back, because the blue station only needs to check for signals on the blue frequency. And then we have different frequencies for the 3 stations. So there are 3 different frequencies here. And then these are all check frequencies, because the receivers will be responsible for check frequencies, and the transmitter will be responsible for open frame and close frame frequencies. So and now I hope this works. So fingers crossed, chamber 2 on the blue station. This should give us the activation of this second endoperistalsis chamber right here. Hopefully. Sometimes it takes a few tries. I really hope that it does work. If it's not working, we can also try on the other station. Sometimes the timing gets messed up and it's not working, and then I try it other times, and then it suddenly starts working. Okay, let's try the orange station over there, since this is, for some reason right now, it doesn't want it to work. So there we have it. There we get transported marvelously. This should work the same time, the same way. Yeah, it's sometimes these receivers misfire, so I've created them here in a way that if there's a signal received, then for some time the endoperistalsis chambers are primed, and then if it receives another signal, the signal will get through to the endoperistalsis chamber, and if not, it's just gonna deactivate again. So this way, when there is a single misfire, you don't get accidentally transported somewhere. Yeah, and this is also why we have 2 different modes here. If we click the node block, we send a single wireless pulse, and if we click the button, we send 2, and we have to send 2 pulses in order to get through, to first prime the station and then to get through. Okay, I also put like the world download and the schematics in the description, so you can check all of this out by yourself. Yeah, also check out Cubicmetre's video. He has got a different protocol that uses a 6-bit packet with a binary encoder, which is also great, but for me it was a little bit too complicated. I like this design more. And also at the same time, you can also use these transmitters for a single frequency right here. Like this is a universal transmitter, and this is a specified transmitter, or like a very specific one. Okay, what else is there? Okay, yeah, one more thing maybe. The endoperistalsis chamber is just really straightforward. It's a small little chamber that is like 2 bubble, 2 water blocks, salt, sand, and honey. I really like this design. It's quite easy if it lets me, so right here. And then just the trapdoor gets powered. That's all there is to it. So really simple. Okay, I hope I didn't miss anything. Yeah, I hope you enjoy, play around with it, and maybe you can create your own endoperistalsis chamber network. And yeah, bye bye.